All right, so in the next section here, what we're going to be talking about is doing really just some basic introduction to Cisco iOS. We're also going to be doing our very first discovery where we're going to actually do some configuration of Cisco iOS. But just like any other vendor's platform or just like any other device, PC, laptop, desktop computer, router, switch, etc., we run a specific operating system in Cisco iOS, or it's called Cisco iOS, or Cisco Internetwork Operating System. Now, the class is not going to allow us the opportunity to go through every single possible combination of commands or configurations with regard to Cisco iOS, but what we will do is we'll get into quite a bit of discovery on how to navigate the operating system. What are the different modes of operation? What are the different functions within the iOS? And so that when you do eventually start to get out there and start doing configurations in other vendors or other platforms, whether it's a router, a firewall, a switch, whatever it might be, you'll have enough exposure to the operating system to feel pretty comfortable kind of trying to navigate yourself through and figure out how the operating system works. And that's what the focus of this particular section is in this particular case. So as a network engineer, obviously you're going to have to be able to use what we call the CLI, or that stands for Command Line Interface, to be able to configure your device. The CLI is loosely based on a Linux operating system. So if you're familiar with Linux or various Linux commands, you should feel pretty comfortable navigating through Cisco iOS. How many of you have had exposure working with Cisco iOS in production environments? Most of you? Yeah. And you'll see that a lot, especially when people come take a Cisco class. They've already had at least some experience working with Cisco iOS. Now, we're going to see slight differences, obviously, between, say, configuring a router versus configuring a switch versus configuring a firewall. But overall, the overall process is still the same. So we need to be able to identify how we're going to navigate through different modes of operation, right? What is privilege exec mode? What is level 15 versus level 1? User exec mode, and so on. So we'll talk about that. And then we'll also talk a little bit about the context-sensitive help in this particular case. How do I use the context-sensitive help to identify what types of configurations I'm trying to apply or trying to create, and so on. And we're going to kind of go through several different pieces here. Now, as far as the operating system itself goes, it's going to have some basic features and functions, right? Just like any other kind of computer system or any system that's relatively similar to other systems like a Windows operating system or a Mac operating system, you're going to see a lot of the basic functionality. That doesn't mean you can't add additional peripherals or add additional applications or software to make it kind of custom, but overall, Cisco routers, Cisco switches, Cisco firewalls, even to an extent access points and other Cisco devices are going to have a very similar structure in how we navigate through the operating system. So for the takeaway from this particular section here is that you guys feel comfortable with that general architecture, that general structure. Like I said before, you're not going to have on the exam, you're not going to have simulations that you're going to have to do for the exam. But obviously, we're going to be doing quite a few discoveries in this particular case. So iOS delivers basic functions, right? Support for basic functionality. If it's a switch, basic switching functions. If it's a router, basic router functions, and so on. Connectivity options to configure things like interfaces, to set up interfaces for IP addresses or speed and duplex, security, whatever it might be, and other kind of configuration elements, if you will. All right, so we're going to take a look at what the iOS software looks like, and we're going to take a look at, how we kind of navigate through that operating system. Now, there are some devices in Cisco's portfolio that don't use native command line. They use a GUI, or graphical user interface, to configure them. Some devices give you both options. And there are even some third-party applications or even Cisco-developed applications that allow you to manage these devices through either like Cisco Prime, maybe it's Prime Collaboration or Prime Infrastructure, or manage the device through some sort of graphical management platform. Certainly when we get into Cisco DNA and software-defined networking and software-defined architectures, then you really see a lot of options for configuring these devices. So the graphic that you're seeing here is basically just side by side a comparison of maybe a GUI-based administration console. This happens to be a Cisco wireless LAN controller, and in this particular case we're configuring a wireless LAN, specifically setting up an SSID and then setting up the security mechanisms, right? And then this is our command line, right? Our command line, which we can access through some sort of terminal application. Now, I like to use PuTTY, P-U-T-T-Y, but obviously there's a whole bunch of different CLI or terminal applications that you can use. Secure CRT, TerraTerm, Super PuTTY, PuTTY, etc. But once you access the device, you need to start configuring that device for its basic functionality. Not very many Cisco devices come with any kind of usable functionality out of the box. You're going to have to connect to that device using the console port, the out-of-band management port of that device. You're going to have to launch your console application, your terminal application, and then you're going to have to start configuring that device from that perspective. All right? So CLI, the initial connection, if you will, let me pull up a better graphic than that one. It's not a very good graphic. Hold on one second here. So let me just pull up a diagram. I'll just do a Cisco 2901 and back. Enlarge, and we'll pull up this image here. It's not a great image. Let me see if I can find a. All right, finally got a picture here. This is actually a 4400, so that's even better because it's really one of the newer platforms that Cisco provides. But when you look at the back of this device, this is actually has a couple of different management interfaces. But these two interfaces right here, this console port and this auxiliary port, there's a USB, micro USB port as well. These are my out-of-band management ports. These are the ports that allow me to kind of initially configure that device and set up that device. This blade right here is actually a server blade, so that's why it has a different type of console connection. But what I'll do is I'll plug in using my rollover cable. I'll plug into that particular port so I can gain access to the command line and I can start configuring that device. When we're using GNS3 in class here and you connect to the device through the console in GNS3, you're simulating a connection to that particular port. It's just a terminal port, a dumb terminal port. It's an ASCII terminal port that operates at 9.6 kilobits a second. So it's not very fast, but it doesn't have to be, right? It just provides us a way of gaining access to the command line interface. Now, once I've enabled the device, once I've configured the settings, and I've gone through and set up all the interfaces, and I've connected the device to the network, assuming I've configured everything appropriately, then I can start managing that device in-band. And in-band management means that I'm managing it by using SSH or Telnet to actually manage the device over the network. But that's not an option available to us in the beginning. In the beginning, we have to configure the device for its basic configuration using that console port. And that's what they're basically showing you here in this particular diagram. You've got your PC, you got this console cable, you plug into the console port, and you use your application like PuTTY or Procom Plus or whatever you decide to use. to connect to the device, your terminal application, and you connect to the device and start to do your configuration. Now, as far as the actual auxiliary port, this port that you see here, it's really just the same type of interface. The only reason that we have two of them is that the aux port is intended for a modem to be connected, so that you can dial into a modem and then you can use that modem to communicate to that console port or to that out-of-band management port as if you're physically on site. The reason why you would do something like that is there are scenarios in which are certain things that you can only do when you're physically attached to the device. For example, reboot the device and boot into ROM-mon mode or remote monitor mode or ROM monitor mode, read-only memory monitor mode. Or if you're trying to do, maybe you're trying to turn off the iOS resiliency feature or image resiliency feature, you can only do those types of things when you're physically connected. But it's not always very practical to be physically connected to the device because it might not be located, you know, where you are or the location that you're at, and you just can't get to it very easily. All right. Once you do get into the console, and we'll play around with some of the options of that a little bit later on, but once you do get into the console, this is where you're going to start executing your various shell commands, your various CLI shell commands. We can configure the device through the console. We can do active monitoring through the use of debugs. We can do snapshot monitoring through use of show commands. We can obviously manage the operating system, the flash file system, which is your hard drive, basically your solid state hard drive on the device. So essentially anything that we need to do, we do through the CLI, all right? Now it says here the CLI is used to enter commands. Operations are going to vary based on the type of device. Clearly, you're not going to have the same types of configuration commands available to you for a router that you would have for a switch or firewall or whatever. We type in or copy and paste entries into the console, and then each of there are prompts that display what mode of operation you're in on that particular device. And that's part of what we're going to be going through in this section here, is identifying what the different modes of operation are. I'll probably expand beyond what's in the text and talk a little bit about some of the other features of the different modes of operation. And then we execute the commands, right? And they show us kind of an example of this. So I'm going to actually kind of demonstrate this as a live demonstration rather than just using this particular output. That's why I wanted to get my GNS3 up and running. But I'm going to use a switch as an example. So let me pull up my switch here. Console. All right. This is actually one of the switches that we're going to be using in our topology, but I'll go ahead and just kind of use this as an example. Let me change the font size there. It's a little bit large. Let's see, change settings, appearance, and let's go with like probably a 20. All right. So what you're seeing in this particular case is really the first mode of operation. We call this user exec mode. User exec mode. The prompt will always kind of indicate what mode of operation you're in. That greater than symbol shows me that I'm in user exec mode. Now, if I do show privilege, I can see that my current privilege level, there we go, that's the full command. You can abbreviate commands, we'll talk about that in a minute, but I'll go ahead and type the full commands for now. You can see that my current privilege level is level number 1. There's actually 16 different levels that exist in a Cisco device, levels 0 through level 16. Now, if I do enable 0 as an example, show privilege, you can see that I can't even run that command. Level 0 is basically nothing. You don't have access to do anything. Nobody ever goes into level 0 because there's actually nothing you can do at level 0. I can type enable to go to a different privilege level. I can exit, I can type log out, but that's pretty much it. Notice what I did to see what commands were available. I simply typed the question mark. That's what we refer to as context-sensitive help. It allows me to identify what level or what commands are available at that particular level. So if I say, for example, enable 1, actually I'll have to restart the device because I didn't set up any authentication. So let me just do that. Stop it and start it again. All right. I didn't configure any of the authentication, so when I went out of level 0, I wasn't able to go back into a different level. I'll talk about what we see here, but while that's rebooting that device, I want to talk a little bit about what I was just mentioning here, user exec mode. User exec mode is actually primarily level 1. Level 1 meaning you have some basic user functionality, but you don't really have a whole lot beyond that. In fact, let me show you what we have access to at this particular level. Let me change this back to 20. All right. So again, I'm rebooting the device, and it should automatically put me into privilege level 1 as soon as all the interfaces boot up here. All right, so again, show privilege. You can see I'm in privilege level 1. All right, now if I do the question mark here, I have a lot more commands available to me than level 0. You can see there are actually quite a few commands that are available at this particular level, but there are some commands that are not available. Like, for example, the copy command. The copy command is what I would use to manage my file system. The configure command is not available here. The reload command is not available. So even though I have some basic troubleshooting tools, I have some basic verification options at level 1, I cannot configure the device. I can't modify the device's configuration because I'm not in a privileged mode of operation. All right? And that's what they're really talking about right here when they say user exec mode allows you to execute only a limited number of basic monitoring commands because you don't have the ability to configure the device. You don't have the ability to modify or manage the file system, etc. Okay? Privilege exec mode is really just any mode above level 1, level 2 through level 15. For example, if I type enable 15, notice that my prompt changed to the $, right? Hashtag if you're a millennial, all right? But that means that I am now in a privilege level. If I do show privilege now, you can see my level is 15. Now if I do a question mark, now you start to see things like configure or copy. Copy allows us to manage the file system. Or you can see delete, so we can delete files. You can see things like, probably one of the more important ones, configure, all right, because I'm at level 15. Also notice, because I'm connected to the console, there's a lot of commands available here, but one of the other ones is that you get when you're at privilege level 15, which is very useful, is this command here, debug. Debug allows you to capture information in real time about the device, whether it's packets that are being routed by that particular device, or maybe you're debugging a routing protocol messages or something like that. You can see that with the debugs. All right, but clearly we have a lot more than we used to have when I was just at level 1. But what about levels 2 through 14? What kind of commands are assigned to levels 2 through 14? By default, nothing. 2 through 14 are customizable levels. So those are levels where you can actually take the copy command, for example, and you can move it to a level 7, or you can move it to a level 10 or whatever. Here's the thing, when you provide access to a user, if you give that user level 8 access, for example, they're going to get access to level 8 and below. Everything below level 8, 8 inclusive, of course. So being at level 15 means you basically have access to every single level. All right? You'll notice it didn't ask me for a password when I went from level 1 to level 15. That's because I'm physically connected to the console, and by default, there is no password to get to privilege mode. That is obviously something that we want to configure initially as part of our configuration. There are other modes of operation. We already talked about the first two. We talked about user exec mode, and we talked about privilege exec mode with the different levels. But there are other modes of operation as well. For example, if I type configure terminal, notice my prompt changed to a parentheses config. This is what we refer to as global configuration mode. Global configuration mode is where you're modifying the configuration elements that apply to the device as a whole. So for example, changing the name of the device, or maybe setting up a static route for that particular device, or maybe it is turning on a service for that particular device, right? So we have lots of different services that we can enable and so on. So again, global configuration mode would be any configuration that really just applies to the device as a whole. I could go into interface gig 00, for example. I've abbreviated it, but interface gigabit Ethernet 00. Notice my prompt changed to config-if. This is what we refer to as a sub-configuration mode. Everything I do at this point only applies to that particular interface. So maybe I put a description, or maybe I put an IP address. It's a switch, so it can't do that. But maybe I put the speed or the duplex or something like that, right? These are configuration commands that would apply to this interface alone. What if I did, say, router EIGRP 100? Notice now I'm in config-router mode. So these are all the configurations that would apply only to this EIGRP autonomous system. IP DHCP pool test, for example. Notice now I'm in DHCP config mode, configuring specifically this pool. So always pay attention to the prompt, because the prompt not only controls what commands are available, because only the commands that are usable in that mode are going to be available in that mode, but also pay attention to the prompt, because you might be configuring and then all of a sudden you realize, oh, I'm not in the right interface, or I'm not at the right prompt. Maybe commands aren't working, or maybe you're just applying commands to the wrong interface or whatever. So always pay attention to the prompt, because it constantly changes as you're going through the configuration of the device. So we talked about global configuration mode. Those are all of my global configuration parameters. And then we have, I don't know how many various sub-configuration modes. I mean, there's hundreds of sub-configuration modes. For example, if I come in here and I say access list 100, let me do it the named way, IP access dash list standard my list. So now I'm in configuration mode for a standard ACL, standard named base ACL. So again, just pay attention to the prompt, because the commands that are available here are not available in a different mode, and vice versa. These are commands that are specific to this particular mode of operation. Okay? Now overall, when you actually look at the configuration, we'll talk more about the file system a little bit later on, but when you actually look at the configuration is broken up into different sections. All right? So for example, anything that is left justified is going to be a global command. Those are commands that you would apply globally. Anything that is indented me go to an interface so I can show you what I mean. Anything that's indented is going to be a sub-configuration command. So negotiation auto would have been a sub-configuration command that I would have executed after I went into global config first and then went into this interface config mode. Does that make sense? So you'll see that the running configuration or the actual working configuration output is kind of organized in a hierarchical structure to identify what commands are global, what commands are not global. So pay attention to that. The exclamation marks are just basically just comments. So an exclamation mark in this case is just used as a kind of a space to break up the configuration. So it just makes it easier to parse the configuration and read the configuration. All right? They're kind of random. Like sometimes you'll see one, other times you'll see more than one, but it really just is, those are intended to kind of break up visually what the configuration looks like as you're analyzing it. All right? And we'll, again, talk more about how do I verify the config and how do I verify what I'm doing in the configuration based on some of the other discoveries that we're going to be doing a little bit later on. All right, so pay attention to the prompt because the prompt will show you what mode of operation you're in. Very, very important. All right, so when it comes to these different modes of operation, like I said, the prompt is really the most important thing. User exec mode is the greater than symbol. Privilege exec mode is the pound sign, but the pound sign is used for any level above 1. So the pound sign doesn't always necessarily mean level 15. It just means not level 1 or level 0. All right? All right. Now this table is just kind of a rehash of what we've already talked about and what I kind of demonstrated. And by the way, when you're in the command line, there's a couple ways to navigate through the command line. Let's say, for example, I've gone into interface gig 00 and I want to go back to global config. If I simply type exit, it takes me back one level. If I type end, it takes me all the way back to my primary prompt. So depending on where you're trying to go will depend on whether or not you're going to type exit or end, but you don't always have to do that, right? I could, for example, come in here and type interface gig 00, and then I do my configurations, and then I can move over to interface gig 01 directly. I don't have to go back to the main prompt and then go back into the other interface. I can shift from one interface to the other, and I can actually even shift from one configuration mode to the other. You guys saw this before where I said IP DHCP pool test 2. Notice that that would normally be a global configuration command, but the device is smart enough to recognize what I'm trying to do, so they automatically moved me to DHCP configuration mode. All right? There's a lot to talk about here, right? Like, for example, what configuration am I modifying? How do I save my configuration? How do I verify my changes? Those kinds of things. We'll talk about that stuff a little bit later on. All right? So again, what you decide to configure specifically we'll get into more, because as we do each of our discussions and as we do each of our discoveries, we'll get more and more into actually doing the configurations. But in this particular case, what they're trying to show you is the description command as an example of one particular type of command. Description commands are nice because it allows you to describe what a particular interface's purpose is or what it's used for. If I go, for example, into my device here, and let's say this interface gig 01 is my connection to the internet. So I might say description. Notice I can have up to 200 characters in my description. So it can be a pretty detailed description. This is my connection to AT&T. And I might even put in here the support number, maybe a contract number, 45678 or whatever. Because if I'm trying to troubleshoot this internet connection, or if I'm trying to troubleshoot this circuit or whatever it might be, having that in the description can be very helpful because you don't have to search for it anywhere else. Hey, that T1 is down. Well, let me look at the description and see what the support number is and what the circuit ID is for the T1. Otherwise, you have to go to the panel and maybe get the circuit ID off the label on the panel or off the NIU or something like that. It's not very practical. So descriptions can be very, very helpful in identifying not only where the connection goes, but you can actually have other really helpful information in there that saves you a lot of time in troubleshooting and so on. So just something to think about. If I do a show run interface gig 01, you can see that description is listed there now. This is my connection to AT&T, phone number, whatever. I just made some numbers up, but you get the idea, okay? And on the right side here, they're just kind of describing how you can move from one interface to the other. Like I said, exit will take you back one level, but you don't have to go out of interface configuration mode to move to a different interface. That's not necessary. You can move from one interface to the other. You'll also notice as I've been typing, I've been abbreviating a lot of the commands. And that is something that you're allowed to do with this Cisco device. Let's say, for example, I want to do let me do a show command, right? Show IP interface brief as an example. So what I did is I typed in enough characters for the device to know what my intention was. It's not a matter of you have to put in at least 3 characters or at least 4 characters. Sometimes you only have to put in 1 character. But what do you have to do? You have to put in enough characters so that the device knows what you're trying to accomplish. For example, if I did, let's see, CT, right? Now I'm thinking, okay, it's configure terminal. But it gives me an error and says ambiguous command. Well, that's because it doesn't know what C command I'm trying to run. Am I trying to run calendar? Am I trying to run CNS? Am I trying to run CD? Am I trying to run clear? How many characters would I have to type in order for it to distinguish configure from everything else? CONF, right? CONF is the only command. The CONF are the only characters, got an extra character there, that allows me to uniquely identify configure. Even CON would be ambiguous, right? Because am I trying to do configure or am I trying to do connect? It doesn't know. So conft works perfectly. That's because with configure, there are no other T commands. There's only one T command. So in that particular case, I only have to use 1 character for the device to identify that I'm trying to type the word terminal. Does that make sense? All right. So you can abbreviate commands. You can also actually do tab completion. So you can put in the characters and hit tab, and it will fill out the command, assuming it knows what you're trying to do. I do that a lot when I'm doing my configurations because I want you guys to see the whole command. So for example, int tab, interface, gi tab, gigabit Ethernet, 00. So tab completion is very useful because it allows you to first of all, verify that what you're typing is valid. Because if you're hitting tab and nothing's happening, so for example, if I come here and hit C tab, 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 it's basically not doing anything because it doesn't know what to do. See what I'm saying? So if I type CONF tab and it fills out the command, I know it was a valid command. Does that make sense? There's all kinds of little tricks you can do with the Cisco IOS. I'll show you some more of them that are probably not in the book as well a little bit later on. All right? So what we're going to do now is we're going to move into our very first discovery, our very first lab for the class. All right? So let's go ahead and load it up and we'll get started. All right, so throughout the course, we're going to be doing a lot of different discoveries, probably about at least 20 different discoveries throughout the course, maybe over 30 discoveries. There's 36 actually included in the course itself. I don't know if we'll get to all of them, but basically these discoveries are our labs. These are labs that we do together as a group that are topic related, that allow us to either configure or verify or play around with, whatever you want to call it, the topic at hand. And in this particular case, getting started with Cisco CLI, which is our very first discovery. So in this particular activity, our focus is going to be basically navigating through the different exec modes, looking at the context-sensitive help, looking at some of the specific error messages that you might get, and then also I'll show you guys beyond the scope of what's in the discovery some other ways to parse the configuration, to parse outputs and so on, and basically just kind of an everyday way of being able to navigate through the command line, and that's really the most important piece, right? You can learn individual configuration pieces, you know, from looking up Cisco documentation and so on, but unless you're really comfortable about how to navigate through the command line and how to use the command line, being able to configure something is going to be a lot more challenging. So that's what this particular discovery is all about. Now, one other thing I want you guys to pay attention to as we move through the rest of our discoveries throughout the course is always pay attention to the topology diagram in GNS3, because even though we're using the same physical devices, the interfaces don't always match up, because the interfaces that are available in GNS3 don't necessarily match up with what's in the book. So just pay attention to that. I try to match them up as much as possible, but they rarely match exactly. So just pay attention to what interface you're in. As far as the actual device names and so on, it's not something that we're too concerned with. So instead of, for example, PC1, the book says it's Ethernet 00, we're saying here it's Fast Ethernet 00. And instead of using Ethernet interfaces on our switches, we're using gigabit Ethernet interfaces on our switches. So just pay attention to that as part of the exercise. All right. So we do see in the discovery documentation, let me pull that back up real quick. We do see our topology diagram, which we just saw in GNS3. We got basically a router and a couple of PCs that are connected to some switches. These are the kind of the device information. You know, switch 1 is linked to switch 2. Switch 1 gig 01 is linked to PC 1, and so on. So the first task is to navigate between different exec modes. So they want us to go into switch 2 and basically press return. So let's go ahead and open up switch 2. You're going to go into your GNS3 console, right click, and then simply click the console option, and it should bring up the terminal window for us. Right here. And you'll notice that I am in user exec mode. We had already talked about that. The greater than symbol represents that user exec mode, which is privilege level 1. And again, show privilege will actually show me the privilege level that I'm in. I already mentioned this as well, the question mark. The question mark will tell me all of the commands that are available at this particular prompt. Not on the device as a whole, but at this particular prompt for this particular type of device. You can see on the left, you see the actual command name, the actual syntax, and then on the right, you see the description of what that particular syntax is supposed to do. All right? Now, you can scroll through each page at a time by hitting the space bar, or you can scroll through, let me do it one more time, question mark. You can scroll through each line one line at a time by hitting the carriage return or the return key, or the space bar to go one page at a time if you'd like to. All right, so you can see there are tons and tons of commands. This is just one mode of operation, probably the least useful mode of operation, being that it's just user exec mode, meaning no configurations or anything. But we already have, you know, what, 50 or so commands available to us. So it's completely impractical in this class for us to learn every single command. It's more important for us to learn how to navigate through the iOS and make sure we feel comfortable navigating through the operating system. So step 2 was go ahead and execute the question mark so you can see what types of commands are available. Like I said, you can press the space bar to scroll through, or you can press the return key. Step 3, as you just saw when you were presented with the more prompt, and by the way, that's not just in this case, it's any time you would have more than one page. For example, let me type a show run, and you'll notice that it will list the first page and then it pauses. You see the more at the bottom of the screen, so if I hit spacebar, it basically scrolls through a page at a time, versus the return character, which only scrolls one line at a time. All right? So that's just something to keep in mind. All right? You can actually change the characteristics of the terminal window or the terminal session to not give you that scroll option. It could just publish everything all at once. You can change the page size and everything, but we're not going to do that right now. Okay? So you can also use the Enter key to scroll one line at a time. You can use the Control-C to stop the feedback or the output, if you will, and so on. So there's a lot of different shortcuts as well. And again, we're going to be seeing a lot of this stuff as we go through some of our other discoveries. And so we're going to see kind of more about this later on. Entering exec mode. Exec actually in this particular case stands for execute, right? Privileged execution mode, where we can execute commands. Like I said, there's 2 modes of operation. User exec mode, which is privilege level 1. That's the greater than symbol. And privilege exec mode, which is the pound sign, which indicates, they call it the octothorpe. I should start calling it that. That sounds a lot better than pound sign. But the octothorpe means that you're in some sort of privileged mode of operation. We already talked about this in our lesson. Levels 2 through level 15 will show you that pound sign. So just because you see the pound sign does not necessarily mean that you're at level 15. It just means that you're above standard user mode. Granted, the only 2 real modes that we ever use are privilege level 1 and level 15, because those are the only ones that are actually kind of pre-configured with some functionality. But again, level 15 is where we like to be typically. All right? There's a typo there. It shouldn't say it in the parentheses. It should say pound sign. I don't know why it says it, but all right. Should have the pound sign. By default, no authentication is required when you're accessing user exec mode from the console. That means out of the box, basically, authentication is not configured. And one of the later on discoveries that we'll do, well, actually one of the very last discoveries that we do in the class, is securing the platform. We used to do that first, but Cisco has moved it to the end, where we learn how to basically lock down our device so that it has passwords for console access, it has passwords to get to privilege mode. We'll talk about things like service password encryption for encrypting plain text passwords and so on. All right? So user exec mode, like I mentioned before, that's just going to give us limited insight to the device. We can't configure the device. We can't modify the device configuration. All we can do is basic troubleshooting and verification. Not even advanced troubleshooting. We can't do debugs, for example, in user exec mode. And there are certain show commands that are not available. I mentioned this in the lecture, right? I'm going to go into privilege mode just to show you this, but show commands allow me to kind of see what I call a snapshot in time. So show IP route would be an example of my routing table at that particular moment. All right? Whereas a debug is used to identify transactional events that are occurring as they occur. So for example, debug IP ICMP. So if for some reason this device responds to a ping or generates a ping, it's going to show me the debugs that are related to that particular ping happening. So debugs are used for kind of real-time troubleshooting, if you will, where you want to see transactional events as they occur, almost like a Wireshark capture, or almost like you're actually verifying that something is actually happening, versus a show is just really a snapshot in time. Be careful with those debugs, because the debugs can tax the router or the switch. If you did, for example, a debug all, which I've never understood why that command is available. That runs every single debug available on the platform. It will crash within a couple of milliseconds. But for some reason, it's available. I don't know why. But even like a debug IP packet is a pretty robust debug. We don't have a lot of stuff going on in this network. But for example, if I do a ping, you're going to see there's a lot more information that I'm capturing now based on that particular debug. Look at all that information just for 5 pings that were sent out. So you could see where if you run the wrong kind of debug, you could easily crash the router because it's just trying to generate too much information. All right? All right. If I could type correctly. Oh my gosh, disable. Disable, there we go. That's why you use the tab completion. All right, so user exec mode only offers a limited set of commands, basic monitoring commands. It's basically what we refer to as a view-only mode. It doesn't allow the reloading of the device. It doesn't allow configuration of the device. It doesn't allow us to modify passwords. It doesn't allow us to manage the file system. So really not a whole lot of use with that particular mode. Privilege exec mode, on the other hand, the opposite. What I call privilege exec mode provides you the keys to the kingdom, if you will. All right? Gives you the keys to the kingdom, meaning that you can do just about anything with privilege exec mode. That's assuming, of course, you're at level 15. Like I said, you can move commands to lower levels, and you can provide somebody access to only the lower levels. So just because you do see that pound sign doesn't necessarily mean that you're at level 15. If, for example, I did have some commands that were placed into different levels, maybe a level 10, I would say enable 10, or I would say enable 5. Sorry, enable 5. But if I just type enable, that takes me to level 15 automatically. You could type enable 15 if you wanted to. But again, notice it didn't let me go to level 10 or level 5 because they haven't been configured yet. Those levels exist, but they're not operational. They're not configured until you've set a password for them, and then you've placed commands in those particular levels. Keep in mind, if you give somebody level 15 access, as an example, they get access to every level below 15 as well. If you give somebody level 8 access, they're not just getting access to level 8, they're getting access to level 8, 7, 6, 5, 4, 3, 2, 1, and 0. All right? To go back to, well, there's a couple ways you can go back to level 1. You could say enable 1, and that takes you back, or you could just simply say disable, and that will take you back to level 1. All right? You can set a password for level 1. You can set a password for any of the levels. But again, that's something that you have to configure. So that's what they had you do here in step 4 is type enable. Notice the prompt change to the pound sign. And then if you use a question mark, once you're in that particular mode, enable, you can see that you have a lot of other commands available. Like I said, and I showed you guys this in the lecture, configure, copy, debug, delete, directory. These are all commands that weren't available in user exec mode. So we have a lot more options in this particular case when we're in this mode of operation. All right. Type disable, that was the next step they had you do. Like I said, you could type enable 1 or you could type disable. Disable, which I, for some reason, cannot spell today. I don't know why. So I probably would have been better off just typing enable 1. But notice that takes me back to user exec mode. All right. Any questions so far? I know this is pretty basic stuff, but it is important because it does provide us really that foundation for being able to navigate through the iOS. This is a switch, but it's going to be very much the same for a firewall, very much the same for a router. So in task 2, they want us to take a look at context-sensitive help. So we're going to go back to switch 2 and we're going to type the enable command. So, I mean, I know this is a little bit repetitive. We've already kind of seen this, but, you know, it's a first discovery. Let's go ahead and kind of go through it here. But they want us to go back into privilege mode on switch 2 and just take a look at a lot of the different commands. Now, really what they're trying to show us here is they're trying to show us in this particular case how you can use the question mark to navigate through commands. And I'm going to actually demonstrate that. I'm going to kind of skip over this here and go down to step 3. And then I'm going to demonstrate here. So let's say I'm in privilege mode. And I know, I know that the particular command that I'm trying to run starts with the letter S. But I don't necessarily know what the syntax is. I simply type S question mark, and it lists all of the commands at this particular prompt that start with the letter S. Or maybe it's an SO, and I want to see all the commands that start with SO, and so on. All right, so let's say, for example, it's CL. Oh, it's clock? Yeah, I want to set the clock. So, but I don't know what that particular command syntax is. Notice when I hit clock and return, I got an error that says incomplete command. So that tells me that it recognized the word clock, but there's some other subcommands that have to be executed on top of that particular command. So I can simply use the clock and hit the space bar, put a question mark, and I can see what subcommands are available with the clock command. Hey, clock set. So I go ahead and type set, hit return, incomplete, up arrow, question mark, and now I have to set the time in hours, minutes, and seconds. This is a description of the command. This is the format of the command. So 10, 10, 10, question mark. Now notice here I have two options. When I have more than one option, it doesn't necessarily matter the order of the options. It just matters that you use one versus the other, or both actually. So in this case, I can set the day of the month as a numerical integer, or I can set the month of the year as a name. Whenever you see text here in all caps, that means that they want you to actually type text. When you see text in lowercase, that means that that is the actual syntax. So that's a key difference, right? Typically, it would say word, W-R-R-D, but in this case, it says month. So they want the month. So let's say June, and then 20th, and then I can set the year. Of course, Cisco's Armageddon is 2035. Nobody's going to exist after 2035, but might not exist after 2020, actually. But so anyway, I've successfully updated the clock. Now, if I were to do a question mark at the end here, all I see is a CR in the brackets there, or the greater than and less than symbol. That basically means, hey, carriage return, there's nothing else that you can type. There's no additional subcommands available. So the useful thing about the question mark is it does allow you to kind of navigate through the iOS as well. And I still use the question mark all the time, actually, when I'm trying to navigate through the operating system. I have a general idea of what I'm trying to accomplish, but I can't remember the exact syntax or the format of the syntax to be able to accomplish the task. In step 4, they wanted to show you about the tab completion. I mentioned that as well. There are instances where tab completion will not work. Of course, it won't work if what you're typing is not going to be valid. So for CL tab, it doesn't do anything because there's more than one command that starts with CLO, but CLO tab or CL, but CLO tab worked. But as an example, if I go, say, for example, into interface gig 00, right? Notice when I type INT tab, it fills it out. GI tab, it fills it out, 00. Now, if I want to move from gig 00 to gig 01, I can do that by typing interface gig 01. But my tab completion won't work here because I'm not in technically the right mode. Interface is normally a command that you would execute in global mode, not interface mode. So there are instances where tab doesn't work even though the command is valid. So just keep that in mind. Tab does not always work even if the command is valid. It just depends on where you're trying to execute that tab command. If I was in global mode, then it would work in global mode, no problem. All right? So just keep that in mind. The tab completion works most of the time. It doesn't always work, but it does work most of the time. And what they're saying here basically is, hey, the tab is not working in this case because I type CON tab, but there are two commands that start with CON. Now, there are some commands that Cisco defaults. For example, srun config, srun. Let me try that again, srun, right? Now, it ran that command, but if I do an S question mark, you can see there are a lot of commands that start with the letter S. But notice what they did here. If I just do S, it defaults to show. So what Cisco does is they take a lot of some of the common commands, some of the commands we use all the time, and they kind of just made them default by one character because you just simply use those commands all the time. All right? All right? You will not proceed to the global configuration mode during this session. Use the backspace key to delete. Yeah, so we're not going to be going into global config. So again, show question mark. Make sure you put the question mark with a space after the command because that means that you're trying to verify the subcommands. That's very, very important. If I did show with just a question mark kind of attached, it would just say, okay, what commands start with the letters SHOW? All right? So again, you can kind of navigate through. So in step 8, they have us do a show R question mark. And we can see all the different subcommands that start with the letter R. Notice there's no star, there's no asterisk here next to any of these, so we would have to type enough characters to make it unique. All right, if I just did show R and hit return, it would say ambiguous command. All right, so it doesn't know what show command I'm trying to run. All right, step 9, again, in this particular case, they're just using the tab completion to tab out a particular command. The running-configuration file, or what we refer to as running-config, is your working configuration of your device. There are two primary configuration files in a Cisco device. There's the config that's used when the device boots up. That's called the startup config. And there's the config of the device as it's actively running. When you're making modifications, and this does depend on the iOS version, this happens to be regular iOS, but there's also iOS XR, there's iOS XE, there's NXOS, there's Cat OS, there's a whole bunch of different variants of OS. But when you're making configuration changes, so for example, I go into an interface and I type description, I'm modifying the running config in real time. So if I come in here and I say hostname SW2 new, notice that the prompt changes in real time. This is a little bit different than what, say, Juniper does and some other vendors. They actually require you to modify the configuration and then you have to apply the configuration for it to take effect. Not in the case of Cisco. So be very, very careful when you're modifying the configuration of a Cisco device, because if you're accessing that device remotely and you're making changes to the config, you have the potential of locking yourself out or whatnot. This is what I will usually do if I'm doing that. I'll go into the device and I'll say reload in 20. Oops, it's not a config command, sorry. Reload in 20. So, and don't save the config. All right? So it says a reload has been scheduled for this time. Remember, this device could be across the country, it could be across the globe, it might not be in an easily accessible location. You don't want to be locking yourself out by misconfiguring an access list or whatever. You can do a show reload to see when the reload is going to happen. So I have 19 more minutes and so on. And then you can do a reload cancel if you've made your changes and you've decided that you haven't broken the device. You can do a reload cancel and it'll cancel that scheduled reload. I don't know how many times this has saved me when I'm modifying the configuration remotely. There have been many times, well, not many, a couple of times at least, where I've been modifying the configuration of a device and all of a sudden I lose my connectivity and then I realize, oh, I just shut down the wrong interface or I just put an access list on the wrong interface or something like that. And the only way to fix it is to reboot the device, right? And somebody has to go do that or you have to spend all night driving across the country, all right? As far as error messages go, we do see several different error messages. We've already seen a couple of them actually. Ambiguous command means, yeah, there is a command that starts with C, but I don't know which command you're trying to run. The other one, like I said, is the incomplete command, meaning that you did type some syntax that was valid, but the command is not complete. There's some additional arguments that you have to specify. Or you might see something like this. Let's do a clock. I'll just actually clock set. You'll see something like this. Invalid input detected at, and then you'll see this circumflex marker. That tells me that their syntax is invalid, obviously. And it actually, the circumflex indicates at what point that command became invalid. It doesn't indicate every part where the command is invalid. It just indicates the first part where the command is invalid. So that is something to keep in mind as well. All right. 3 basic outputs that you'll see: ambiguous command, incomplete command, or invalid input detected at the circumflex marker. All right, unrecognized command, incomplete command, and so on. So pay attention to those 3 outputs. Those are typically generally the 3 outputs that you're going to see as you're doing the configuration. Percent indicates you didn't enter enough characters. Incomplete command means that you did enter the correct syntax, but there's some arguments that need to be made. And invalid input means that's a syntax error. Okay? All right, so again, you can use the context-sensitive help to kind of walk through different commands. Like I said, we can use the question mark. We can use the question mark after a command to see whatever the subcommands are for that particular command and so on. We demonstrated that. All right, which takes us into task number 3, managing our Cisco IOS. All right, so this is about how do I manage the configuration file itself. Like I said, there's 2 different files that exist. There's a startup config and there is a running config. And there's obviously other other files that exist on the device. There's the operating system file. There may be some other system files that are related to that particular platform for configuring that platform and so on. So notice here that, and this is actually something that I had already discussed, immediately after you make a change on the device, the prompt changes or whatever configuration changes. Again, that's because we're modifying the running configuration in real time. So be very, very careful as you're doing your configuration changes to make sure that they're the appropriate changes, otherwise you could break the device. All right, so here's an example where they said, went into global configuration mode, they changed the name of the device to temp, which immediately changed the name, and they hit end. Now, here's the other thing. This is the running config. It is not the startup config. These are two different configuration files on the device. One is stored in volatile RAM, that's the running config. So that means if the device loses power or reboots, we lose that configuration. The other one is stored in NVRAM, non-volatile RAM, which is the startup config. Here, you can take this power supply back if you like. All right. So how do I make sure that the config that I'm modifying is the configuration that is going to be the configuration the next time the device boots up? We have to save that configuration. The other thing that they're going to show us here in step 2 is a way for us to do what we call grep commands. All right? I don't think they call them filtering parameters, but I call them grep commands. That's from the Linux world or Unix world. These grep commands can be very, very useful because a lot of the times we're trying to filter out information in the outputs, and these outputs can be really, really long. They can have a lot of information. So you can filter out pretty much any show command. So for example, I can say show IP route, but only include the lines that have the letter C. Okay? And by the way, the include, I just abbreviated include, but it is case sensitive. So this is my connected route. Or I could say exclude the lines that contain a C. Right? So now it took out all the lines that have a C in them. So you could see where this could be really, really useful if you know generally what it is that you're looking for. Let's say, for example, I want to see all of my interfaces that are administratively shut down. I can do show IP interface, include admin. That's not going to work. How about we do this? Show interface. Let me do this real quick. That is the one thing that you have to be. Oh, yeah, that's right. This is a switch. None of the interfaces are admin down. All right, let's just say I want to see all my interfaces that are down then. All right, show IP interface include down. Right. So it's a way for us to kind of extract information from these outputs. And I use these all the time, actually. They're really, really good time savers, especially if you get really creative. Right? So let's say, for example, I wanted to, let me get an interface that's actually active. Show IP interface brief. So 00, 01, and 02 are up. So show IP interface gig 00. Actually, show interface gig 00. IP is not configured on these because this is a switch. So you can see this output is pretty robust, right? But let's say, for example, I was just looking for something that had a lot of, I want to see if there are any interfaces that have output drops. So I could say show interface and include drops. And I can very quickly pull up a whole list. It doesn't show me which interface specifically, but I could pull up each interface. Now I could get even more creative, and I could say, for example, let's do that same one. Let's do, instead of just drops, let's do giga pipe drops. And now what it's doing is it's pulling both lines. It's pulling the gigabit interface and it's pulling the drops for that particular interface. So you can actually combine multiple greps together. You can't combine multiple operations, right? You can't do an include and an exclude and a begin and a section and all that. But you can get pretty creative with these filters to be able to pull out the information that you need to pull out. All right? And the more you get used to it, the better you'll get at it, of course. But it can be really, really useful. All right? What are some of the grep options that we have? Show, run, pipe. We have append, begin, count, exclude, format, include, redirect, section T. These are all, if you're familiar with Linux and managing files in Linux, you know what most of these mean. The ones that I tend to use the most are include and section. Section is good because you could say, for example, section router, and it will give you your entire router configuration. So like EIGRP, OSPF, BGP, etc. We don't have that here on this device, but you get the idea. All right. So as we go through some more discoveries down the line, you'll see me start to use these grep commands or these filters more and more. So I encourage you guys to kind of play around with those. All right. When a router or switch boots up, and we'll talk about this in more detail in another section later on, the very first thing that device does is it looks for the startup config, which, like I said, is stored in non-volatile RAM. NVRAM is just a partition of your flash. Your flash is your actual physical memory on the device, basically your hard drive, if you will, a solid-state hard drive. That startup config file becomes the running config. So it gets loaded into memory and it becomes the running config. So whatever's stored in your startup config ultimately becomes the running config. That means that if you want all the changes that you've been making to running config to become the startup config, we use the copy command for that. The copy command is a privilege level command that allows me to copy files to and from the device or across different memory locations within the device itself. And you can see there are a ton of different copy options, right? I'm not going to go through all these because that would take forever, but I can use FTP, I can use HTTP as a protocol, I can do startup and running config, I can copy to different flash locations, flash drives, if you will, on the device. I can use TFTP, I can tar files, basically all kinds of file management options here. But the most important one is the copy running config to startup config. The copy command is always source to destination, always. Regardless of whatever you reference, it's always source to destination. So in this particular case, I'm taking my running config and I'm making it my startup config. When you do that, it's a replacement. The startup config is replaced. When you go the other direction, from startup to run, it's a merge. That's also very important to understand. When you're doing anything to the running config, it's always a merge. It's not a replacement. So you could have some configurations that get merged together, and then the device is not going to function like you would expect it to function. All right? Notice when I hit return, it said, what do you want to name the file? And then whatever was in brackets is the name of the file by default. So in this case, startup-config. What if I did want to replace the running config? Let's say I've gone in and I've made a whole bunch of configuration changes. I've modified all the different configurations. And I decided, you know what? I've messed everything up. I just need to start over again. I'm just going to go back to my original configuration. You can't do a copy, start, run. Technically, you can do that command. It is available, right? And I can execute the command. But again, that's a merge. So what I would typically do is I would do something like configure replace. When you do a configure replace, you're replacing the running config. You're overriding the existing running config, and then you can pull the file from any one of these locations. So I can say configure replace nvram startup -config. All right, and then it says you're about to replace your running config. Do you want to proceed? Yes. I hit return, and then it does basically what we call a configuration rollback. It didn't make any changes because I hadn't modified the config. But that allows you to get rid of that merge option, and it allows you to actually overwrite the actual configuration. Okay? We were talking about managing the iOS, and yesterday we talked about the idea of when we make modifications to our Cisco iOS, we're modifying the running -config, right? So if I don't save those changes, if the device reboots, the device powers off, whatever it might be, those changes get lost. Now, one of the things that's important to understand is what types of memory does a Cisco device have? And we can see that listed on the diagram here. There are basically 4 types of memory that Cisco devices have. They have their RAM, which is kind of like your working memory, if you will. We have our ROM. Oh, by the way, and the RAM is where we store our running -config. Remember, when the device boots up, it does what we call a power-on self-test. Once it does, it tests all the hardware and verifies the functionality of the hardware. Then it starts to load the configuration. That configuration file is called the startup-config. That is stored in non-volatile RAM, NVRAM, which is really just a partition of the flash memory that's on the device. Remember, the flash memory is like your solid-state hard drive, if you will, on the router. So the startup config is stored in NVRAM, which becomes the running config in my DRAM, my dynamic RAM. Or again, remember, my dynamic RAM is basically just the memory that I use to process functions within the router. Later on, we'll talk about the concepts of the different planes of existence within a router or switch, the data plane, the control plane, and the management plane. But basically all my CPU functions, building my global routing table, building my adjacency tables, my anything that's going to be dynamically created on that device, whether it's a switch or a router, doesn't really matter, that gets stored in RAM. Now there is a bootstrap code. It's called the ROM, the read-only memory. So every device has this bootstrap code, which is almost like a initialization iOS as well as a recovery iOS. So for some reason, if the regular iOS gets corrupted and the iOS can't load, we can always load into this recovery image, which is stored in on a chip on the motherboard. It's actually an upgradable integrated circuit. It's inserted into a pluggable socket on the motherboard. I've done an upgrade on one of those chips many years ago. Cisco will send you new ROMs if you request them for whatever reason. You just have to open up the chassis and pop out the old chip and put the new chip in. That cannot be upgraded because it is ROM, it's read-only memory. It cannot be upgraded on the fly through software. It has to be physically upgraded. And then the flash memory, like I said, this is really just my working memory. This is my hard drive, if you will. Not the working memory, but my hard drive. This is where my operating system is stored, as well as other files that the router might need or the switch might need to function. Sometimes you'll have a router or switch that provides other features than just basic routing and switching, and you have to have different files in Flash to be able to do that. When you go to Cisco.com and you go to download an image, let me pull this up real quick. You go to download an image, it will tell you in that download section, it will tell you exactly how much. Let me do a 4400. It'll tell you exactly how much memory, how much RAM, how much DRAM, how much flash you'll need for a particular iOS image. So let me just show you that real quick. I'll just pick 4000 series router, and let's just do a 4031 integrated services router, downloads, and let's look at the latest iOS. And you'll notice here, as you pull up the images, it will tell you in this particular case, the file size is 467 megabytes, but you need at least 4 gigs of DRAM and 4 gigs of flash to be able to install this image. You see where it says minimum memory requirements? Kind of like in the middle there. The DRAM is your working memory, and the flash is your static hard drive. So when you're going to load an image, if you're going to upgrade the image on the platform, or if you're going to load an image on the platform, make sure that you have enough memory to support that particular image before you decide to install it. Generally, most images are going to have a pretty minimum requirement, and most of the platforms will support that particular upgrade, but it's always good to make sure. All right? If for some reason you have enough flash to store the image, but you don't have enough DRAM to run the image, the device will just keep rebooting and rebooting and rebooting because there's not enough working memory to actually run that particular image. So it's something to just keep in mind. All right? So we can view the configurations of our devices by simply using show commands. Let me just go into switch 1 here. I can do a show startup-config to see the startup config. And you'll notice that, again, we talked about this previously, but it's kind of broken up into these individual sections with these exclamation points indicating the section separation. There isn't in this particular iOS, there isn't a way to do kind of a side-by-side comparison natively within Cisco iOS. So you can't say, tell me the difference between my startup config and my running config. There are editors and tools that you can use to download the config file and do like a side-by-side comparison. But as you're modifying the running config, you know that startup config is not actually being modified on the fly. So you have to make sure you save that configuration. And we talked about that concept previously as well. All right, so show running config is a way for us to view the current active running configuration on the platform. That is the config that's stored in RAM. Show startup config is a way for us to see the configuration as it is if the device boots up. Configure terminal, we saw this yesterday. We'll see it again today. Configure terminal allows us to go in and modify the running configuration of the device. What about copy run start? Remember we talked about that as well. The copy command provides us the ability to manage the file system. Some of you guys are probably pretty familiar with the write command, like write memory or write terminal. The write command has actually been deprecated by Cisco. Even though it's still part of the iOS, it's not officially supported. So the copy command is really the command that you want to use to manage the file system. And the syntax is copy source to destination. So if I say copy run start, I'm doing a replacement of the startup config. Do you guys remember what I said about the copy start run? What's one of the things that you need to be sure of or be aware of if you're using any kind of copy to the running config? It merge, it doesn't do a replace, exactly. So certainly some aspects of the configuration are going to get replaced. Putting an IP address on an interface, for example, an IPv4 address, you can only have one primary IPv4 address on an interface. So those parts of the configs will get replaced. But let's say I have an access list in my startup config, and I have an access list in my running config that have the same name, but they're not the same configuration. Those access lists would actually get merged, and you would have both elements of that access list put together. So you just have to be careful. Remember what I said about how to get around that? We use a configure replace command, not the copy command. Configure replace. What do you think erase startup config is going to do? It's pretty obvious, right? That's going to erase your startup configuration. So the copy command, and I showed you guys this previously, but the copy command provides a lot of options with regard to where we can copy from and where we can copy to. And you can either just do like a copy TFTP flash, and then what it will do is it will walk you through the steps to say, okay, I want to copy from this TFTP server 1.1.1.1, the source file.bin, and then the destination is myfile.bin. So it will walk you through kind of these steps. You don't have to put in all the elements of the file locations and whatnot in the original syntax of the command. You can just put the general source and general destination, and it will start to walk you through the process of, okay, where's, depending on what type of copy it is, what's the source, what's the destination, what's the file name, etc. It's not actually accessing the TFTP server in this case because I just made up an IP address. All right. Just always remember that it is a copy source to destination. You can see that here in this case, we're doing a copy run TFTP. What is the, well, we didn't really talk about TFTP, did we? So let's talk about that a little bit. TFTP is one of the file transfer options that you have with Cisco iOS. It stands for Trivial File Transfer Protocol. It's a UDP-based application that runs over port 69, and you can basically download just about any TFTP application. I use this particular application here. All right, I don't know why she's talking to me, but I use this particular application called TFTP D64. You can go Google search that and you can find that application. It's a really, really simple TFTP application, very light executable. It doesn't have to run as a service. And it's a really simple application. You specify the directory where you want your files stored. You specify which interface you're going to use as the interface for the TFTP process. And that's pretty much it. As long as that address is reachable by your device, you can send and receive files to your computer using this TFTP application. The only thing is you probably have to allow it through the firewall, right? Cisco used to have their own TFTP application, but they stopped making it. And this is pretty much the one that you see today. All right, this TFTP D32, or there's other ones, right? SolarWinds has their own TFTP application and so on. All right, so in step number 3 of our tasks here, they want us to go into switch 2, and well, we should have already done that. I reloaded my lab, so let me go ahead and do that. They wanted us to previously change the name of the device. So config T, we use the hostname command for that, and we set it to temp. Notice again that configuration change was applied immediately. Now I can do a show run, pipe include hostname if I want to pull out that particular part of the configuration. Remember, when you're using that include or exclude or begin, you have to specify the right case. If for some reason I said hostname with a capital H, it's basically parsing the config file and it's looking for that exact format for that text. So it is a case-sensitive concept. So we can see they did a show startup. So hey, that's okay. We can do that as well. Show startup pipe include hostname, and we can see that the original hostname is still part of the startup config, but my current hostname is temp. So the idea here is that we're seeing that we've modified the running config, but it didn't automatically modify the startup config. All right. Now we can also reload the device. I'm actually not going to perform the reload because GNS3 doesn't always like to work with reloads very well. But a reload would simply reboot the device. And if there's a pending configuration change, in other words, if the running config doesn't match the startup config, it will say, you know, the system configuration has been modified. Do you want to go ahead and save that configuration? And you guys recall from our discussion before, I also told you about the scheduled reload, which can be a huge benefit to you. I'll show you again because this is kind of a new day, but you can do a reload in, and you can specify the delay. You could actually do a reload and specify a couple of different options. Reload at this specific time and date, which means you would specify the actual date and time, or you could say reload in 15, and the device is going to reload in 15 minutes. And you'll actually get messages that pop up on the screen that say the reload is going to occur in 10 minutes, the reload is going to occur in 5 minutes. So if you forget, hopefully you'll see those syslog messages on the screen saying that that reload is coming. You could see why this would be beneficial, right? Especially if you're modifying the configuration of the device remotely. I don't know how many times, probably at least 2 or 3 times, I've been making modifications to a device. In fact, it actually recently happened to me. I was modifying a switch configuration for a device in Australia, kind of far, right? It's kind of difficult to go all the way over there and reload the device. So I actually had to wait until somebody got to the office, and then I had them reload the device. But so a reload cancel will cancel that particular reload. And then, of course, you can just do a standard reload if you want as well to reload the device. All right, so now they want us to change the host name of switch 2 to this will stick. So let's go ahead and do that. We're going to go into global configuration mode. Again, this is a configuration that applies to the device as a whole. So we will stay in global configuration mode. And then, assuming based on the name, they're going to want us to go ahead and save the configuration. Yep, so we're going to do a copy run start. All right, now again, you could do a write. It does work. Again, that's a deprecated option, doing a write command. They wanted us to do the copy run start, which ultimately is the same thing. You'll notice that with the copy run start, it at least gives us an option to change the file name. But because it is the startup config, we don't really want to change the file name. And we can see that the configuration has been applied. So if I do a show start, excuse me, pipe include host name, you can see, oops, I don't need the do, I'm not in config mode. We'll talk about the do command a little bit later on. But we can see that the host name has been saved as this will stick. All right. Again, they want to do a reload. Not necessary. Obviously, we know if we reload the device, it's going to load the startup config that we just applied, and the host name did in fact stick. Yes, that's why they decided to call it this will stick. All right. Now, again, you can do an erase startup config. I'm not sure if this would work in GNS3 or not, but let's give it a try. And let's do a show nvram colon, or dir nvram colon. Yeah, the startup config is still there. Reason it doesn't work in GNS3 is because GNS3 doesn't actually have physical memory, right? So it's not really technically writing the files. It's writing it to the GNS3 configuration folder. But in the real world, that startup -config would be gone. And if you rebooted the device, it would actually go into what we call the initial configuration dialog. In other words, it's going to say, well, there's no startup config, but we need to create some sort of boot config. So we'll go ahead and put you into the initial configuration dialog. Let's try to do the show startup config. I'm sure it's going to say that it's still there, but it says it's not present. All right, well, that's good. It's at least reporting that it was erased, even though it still shows in the contents of NVRAM. Now, the file is 0 bytes, but again, that's more related to GNS3 than it is to the actual file itself. So if you reload the device, in this particular case, now this is a switch. Unlike a router, which has the initial configuration dialog, switches generally don't have an initial configuration dialog. You can actually force it to go into that dialog by typing the setup command, and this is what it looks like. Would you like to continue with the configuration dialog? And if you say yes, it's basically going to walk you through about 20 or 30 different questions about how you want to set up the device. Do you want to set up management of this device? Do you want to set up passwords? Do you want to set up interfaces? Do you want to set up protocols? Honestly, that initial configuration dialog is really a pain because it asks you, it doesn't really give you an option to choose the elements you want to configure. You have to go through the wizard consecutively, which isn't really very practical actually, because there's a lot of questions it's asking that you may not even want to configure. And you can't bypass those steps because it's part of a chronological configuration step. So we don't typically use that initial configuration dialog as part of the config. All right. So verify the hostname parameter in the running config. Had we deleted the startup config, the default name is switch for a switch. The default name for a router is router. And sure enough, that's what it would look like in the config, because again, the startup config becomes the running config. Whatever that might be. If there is no startup config, there's kind of an initial basic configuration that gets applied. That's going to be applied to the running config. All right. Task number 4, Cisco IOS configuration commands. We're going to practice using terminal history, which can actually be very, very helpful. We'll talk about terminal history. We're going to do this on the router in this particular case. So let's go into our router real quick. And we're already in privilege mode, but they wanted us to go into privilege mode, but we're already there. And they want us to kind of go through a whole sequence of commands here. Show IP route, show clock, show IP interface brief, configure terminal, set the time zone to Eastern Standard Time. This is the offset from Greenwich Mean Time or the global clock, and no IP domain lookup. All right, so we'll do these commands. It's not, the point of this particular exercise is not to understand what these commands necessarily do. It's for us to generate some command history so I can show you how the command history works. But I'll do a brief explanation of some of these commands as we go through them. This is a router, which means it's going to be routing. It's a layer 3 device. Show IP route naturally is going to show us our global routing table, what we call our routing information base. You probably have seen that term or heard that term before, RIB, R-I-B, stands for routing information base, or global RIB. And you can see from this output that we see various routes. We see C routes, we see L routes. These are the codes to indicate what types of routes they are. Again, not the point of this particular discussion as to what the specifics of these outputs are. A connected route is basically a route that is attached to an interface on that router. All right, so that was the first command they wanted us to run. Of course, we're going to spend a lot of time going through that a little bit later on. Show clock, pretty obvious what that command is going to do. It's going to show me my time. Let's see, we've got show IP interface brief. This is actually probably perhaps one of the most valuable commands and one of the most important commands that you'll have in any Cisco device. Show IP interface brief. This is, to me, like the Phillips head in your tool chest. It's a command that you definitely want to have available to you because it does a couple of different things. It tells you what interfaces you have on the platform. It tells you the status of the interface, which is my physical layer, layer 1 status. It tells me the protocol, which is my layer 2 status. So this is a really easy way to verify the operational state of the interfaces on your platform. And it doesn't just work on routers, it works on switches as well. Again, we'll spend some more time talking about this command a little bit later on. All right, now they want us to go in to configure terminal, which means we're going to go into global configuration mode. We talked about that before. And they want us to set the time zone. Now, managing the clock on the device, there's a couple of ways we could do that. We can set the time zone, and then it just says word. Remember I said that before. Anything in uppercase means that you're supposed to type something in. Not supposed to type the word. You could do EDT, you could do PST, PDT. It's just the name of the time zone that you're configuring. And then what you're setting is the offset from universal time code. So Pacific Daylight Savings Time would be like a -8 as an example. All right. So that would set the time zone. It doesn't matter what we set it to here. The point again is not the syntax specifically. We're going to be talking about command history in this particular case. All right, no IP domain lookup. That is also a global configuration command that disables DNS queries on the device. It doesn't disable DNS from passing through the device. It just, a lot of times when you're typing in commands on a router, and I'm sure you guys have seen this in your experience as well, or a switch, you might mistype something and it thinks you're trying to connect to another device, or it thinks you're trying to resolve a host name, and it will start to do a DNS query. So no IP domain lookup, no IP domain dash lookup turns off that feature on this device. Let me see if I can demonstrate. So let's do IP domain lookup, and we'll just do test. Might have to get out of config mode here. Let me see. Let me pick something. Bob's router. Yeah, it's not going to do it. Hello. I'm trying to get it to do a lookup, but it might not. It doesn't happen every time. It depends on the specific command. It also depends on the platform, but sometimes it happens where you type in something and then it thinks you're trying to open up a session to a device or something by its name, and it will try to do that lookup. Actually, what I just did was a couple of the things that we're about to talk about here, which is use my command history to modify the configuration or to make changes to the configuration. There are several different shortcuts that are available, and I'm not going to go through all of these because not all of them are very useful, but some of them are pretty useful shortcuts when you're managing the iOS. This one, for example, I actually used just a minute ago, Control A. So what I did was I said, oh, I did no IP domain lookup, but I want to remove that command. In other words, I want to negate the no IP domain lookup, and I want to do domain lookups. So I hit the up arrow. The command history stores up to 30 commands by default. You can change the history buffer and whatnot during the session that you're in. So you can see here that I can kind of scroll through the different commands that I've been entering as part of this configuration process. And it depends on what mode you're in. These were the clock time zone and the no IP domain lookup were the only ones I put in that mode. But if I get out of global mode, then I can see all the different commands that I had typed previously. Show IP route, show clock, show IP interface. In fact, I can do a show history, and I can see what the current history is that's stored in that particular device. And again, you can change how many commands get stored, but it's really, really useful because I can come into config T and I want to remove that or negate that no IP domain lookup. Control A brings me to the beginning of the line, and I can then delete the no, and now IP domain lookup is turned on. Again, up arrow, Control A, put in the no, and that negates the IP domain lookup. By the way, that's kind of important, right? With Cisco devices, to do the opposite. Maybe if I put a description on an interface and I want to remove that description, I just simply put no description. If I put an IP address on an interface and I want to remove that IP address, I do no IP address. So the no in front of a command generally is going to allow us to remove that particular command. All right? So Control A can be very, very useful. Another one that is, I guess, kind of useful is Control C. Control C is almost like a break sequence. Control E can be useful from time to time. That takes you to the end of a line. Control Z was already used for something else. So I could say, okay, Control A, IP domain lookup, Control E, question mark. So I can kind of move back and forth on the same line if I want to. Escape B I've never used. Move the cursor back one word. I mean, just use your arrows, right? Escape F, move forward one word. Control B, move back one character. These command line editing sequences that you have are really there if your arrows don't work. And sometimes in older terminals, you didn't have the arrows that you could use to navigate through. So you would use these control functions for those. So it's not really necessary. Control D, for example, to delete a single character. Well, just hit the backspace. All right. Let's see. What's other ones that are useful? Control Z is useful, of course. That takes you all the way back to the main prompt. So if you're in interface configuration mode or you're in global configuration mode, if you hit Control Z takes you back to the main prompt. Interestingly enough, interface get or FA00, Control C does the same thing. So really, there's no distinction between those two. Control C and Control Z kind of do the same thing. They say Control C aborts the current command and exits configuration mode. Well, isn't that really what Control Z did, right? It aborts the current command. Tab. We talked about tab completion before. It allows you to tab out your commands. Again, if the tab doesn't work, it means that the syntax is probably not valid or you're not in the right mode of operation. So that can be very useful. Control-Shift-6 is an interesting concept because if you're doing a ping or a trace route, it doesn't always work. It depends on the terminal. So if I'm doing a ping 1.1.1.1 and I'll do it repeat 10 times. So if I hit Control-Shift and then 6, it breaks the ping sequence. Sometimes you have to do Control-Shift-6, release, and then hit the letter X. It depends on the iOS and the terminal application that you're using, but generally Control-Shift-6 should work just fine. All right, and then the up arrow or down arrow allows you to navigate through that command history. You're not going to be tested on this kind of stuff on the exam, but it is very useful when you're doing your configurations to be able to understand how to kind of navigate through these different configuration options. All right. So the history, like I said, we can do a show history to see the contents of the history buffer. By default, it stores up to, it says here it stores up to the last 10 commands, but actually I believe it's the last 30. Let me see here. Show history. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me do one more command, show run and show history. Yeah, so it looks like it did only do the 10. So you can change that. The history buffer, and I can't remember I think it's just history. I can't remember the command to change the buffer size, but I'm sure it's actually in here somewhere. Let's see if it's in here. Set the command history buffer size, terminal history. Okay, that's the one I was looking for. So terminal history, and then you can specify the size of the buffer. So even I use the question mark from time to time, or I can't remember every single command. It's not something I typically change very often, the history buffer. Keep in mind, the history buffer is only stores the command for the active session. So if you get out of config mode, or you get out of the console, or you leave the console and come back, the previous history buffer is going to be erased. It's not stored permanently. It's only stored during the session that you're actively in. Okay? All right, but the history does help, and you'll see me as I start to do some configurations when we get into some of our more advanced discoveries later on in the class. You'll see that I actually start to use those arrows and command history quite often and tab completion and all these little shortcuts to be able to implement different configurations. All right, use the up arrow, the down arrow, use the show command. One of the things that I did not specify was the do command. I'm sure it's going to be brought up a little bit later on in our discussion, but I'll go ahead and discuss it right now as well. All right, the do command, pretty important. All right. So let's say, for example, I'm in config mode, and I'm in interface FA00, and I'm interface, let me go, FA00, and I'm putting a description, my interface, and I'm putting various configs. Now, I can't do a show run here or a show run interface FA00 because I'm in config mode. I can't even do a show IP route. I can't do any show commands. I can't do a ping command. I can't do a telnet command. These are all commands that generally you would have to do when you're out of configuration mode, unless you put a do in front of it. Do show run interface gig00 or FA00, sorry, and it will actually execute the command for me. So it doesn't require you to get out of config mode or whatever mode you're in, sub-configuration mode or global configuration mode, to do specific things that you would normally do when you're not in configuration mode, right? Do ping 1.1.1.1, and it does the ping. So the do command is very, very useful because you might want to be intermittently checking your configuration or verifying the steps that you've taken without having to get out of config mode and then go back into config mode and so on. So definitely use that do command a lot. You can also set the number of lines in the terminal session, terminal length. Again, if, let's say, for example, I'm trying to capture a configuration, I'll say terminal length 0. All right. Now, if I do a show run, it actually displays the whole running config without the page-by-page step, right? Without doing the 24 lines at a time. The reason why this is useful is because I can actually set up PuTTY or whatever application I'm using. I can come in here and I can do a change settings. Let me pull it over here real quick. And I can do logging, and I can say, okay, log the session output and browse and put the file on my desktop. And I can do a show run. And basically, I've just manually captured a configuration of my device without the more statements, those more statements that you see for the page, without those as part of the configuration. So you can set the terminal length. And by the way, if you do no terminal length, and no terminal, I guess it doesn't let me do that. What I was going to say is if you do a no terminal length, usually it will just reset it back to the default I guess for that particular command, it doesn't provide that option. So, but you can certainly set it to the standard length. And again, if I do my show run, you'll see now I have the page pagination, if you will. I guess that's what they call it. I don't know. For seeing one page at a time. All right. All right. So leave the configuration mode, Control Z. All right, we'll do that. We're already out of configuration mode. Use the up arrow and down arrow again. So again, they're just kind of showing the different command history that I had applied. Again, it's stored based on the mode that you're in. So for again, if I go into config T and interface FA00, the command history is different here. These were the commands that I had done under that interface, not in global configuration mode. So it does store that command history based on the specific mode as well. All right. So they want us to recall the show IP route. And it's been a while since we did that one. Let's see. Show IP route. Nope, not there, but you get the idea. I'll just put it in again and I'll recall it. So recall just the up arrow and recall the command. All right. Now, what they want us to do here is kind of mistype a command. Snow IP interface brief. Obviously, we're going to get an indication that there's an error. It's interesting that the error isn't at the N, but it's at the O. What does that really kind of indicate to you? That there is actually a command that starts with SN, SNMP. So it says, well, the error is at the O, but really technically in our case, the error was at the N. But I can use my up arrow, hit Control A, use my right arrow, and then I can fix the syntax error, and I can run the command. So I know this is really, really basic stuff. But trust me, the more and more you do configurations, the more and more these little helpful things can be useful to you. All right. Control A, right arrow, backspace, put in H, hit return. We did all that. All right. So the next thing they want us to do is go back to global configuration mode. So we'll go into global configuration mode on router 1. They want us to go into our interface. We're using Fast Ethernet 00. They actually want us to configure a serial interface, which is not really part of our topology, but it doesn't really matter. Let's see, we have 2.0 in our case, not 1.0. So I can go into my serial interface. I should have serial 2.0. Oh, well, not a dot. Slash, there we go. All right, so I was just actually curious why it has an actual address. I think that's a remnant of, because we're not using serial interfaces in our config, maybe that's a remnant of a previous exercise that I had done with this particular topology. But they want us to put a description, so we'll put in our description. And then they want us to do a no shutdown on the interface. Now, the interface is actually already turned on, and we will talk about this later. What is the difference between up, 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 down, administratively down, down? These are very important concepts. But again, this is not the point of this particular discussion. But a no shutdown actually enables an interface. A shutdown disables the interface. Can't type today. All right. And when I say disables the interface, I mean it literally turns off the interface. We can see that the interface changed to administratively down. So no shutdown enables the interface, and shutdown disables the interface. By the way, on switches, interfaces are enabled by default. All my layer 2 interfaces are enabled by default. On routers, layer 3 interfaces are disabled by default. So out of the box, you take a switch out of the box, all the ports are active by default. You take a router out of the box, all the ports are disabled by default. So you do, when you configure your router interfaces, typically do have to bring them up. And you'll notice here, you get a couple of syslog messages indicating that the interface status has changed, right? This is a level 3 message. Let me show you what I mean by that real quick. Cisco syslog levels. This is something that we would see kind of towards the end of the class, but I might as well show you right now. So you can see that we have multiple levels within Cisco here. These are actually not Cisco specific. This is these are protocol specific. But a level 3 is an error message indicating an error condition. Level 4 is a warning. Level 5 is a notification. Level 6 is informational. So when you're looking at the syslog message, you see the -5 in the middle there. That indicates that's a level 5 message. -3 indicates that that's a level 3 message. Saying that the interface came up, I don't know why that would necessarily be considered an error. It's actually, the interface is actually becoming functional. But this is the syslog facility, if you will. This is the actual data about the syslog message. Syslog is an open standard protocol for identifying events and things that occur on a device. It's not specific to Cisco, but it is usable within the Cisco space. All right, obviously. Repeat a similar configuration for serial 1. So what they're trying to demonstrate here, serial 2.1, is that I want to basically do the same thing, but with maybe some minor modifications. So I can go into interface serial 2.1, and I can use my up arrow, and maybe this is a link to service provider 2, and I want to do the no shutdown. So I can use my up arrow, even with the command history, because it's in the same mode. It doesn't have to be under the same interface, but because I'm in the same mode, that command history still exists for that particular interface. All right, and they did a description of SP2, no shutdown, and we see the information. All right, Control Z, of course, takes us back out of configuration mode and so on. All right, this particular concept, the filtering options, we already talked about using the pipe command or the pipe option, what I call grep commands, or grep options. There are 4 major ones that are here: begin, exclude, include, and section. So for example, let's say I do a show run, but I want to do a begin at time, right? So what it's going to do is it's going to find the very first time in the show run that time shows up. And we see that right here, time. It's part of timestamps, but it's still time. Again, begin is case sensitive. All right. If I want to see all the times that time shows up, I can say include time, and it will give me all the lines that have the word time in them. Again, case sensitive. Or I could say exclude time, and I could say, and then of course it would show me everything except for those particular lines. You can do combinations, right? You could say include time, pipe, AAA, pipe, interface, and it will pull out all of those pieces as well. Again, you can't mix and match, include, exclude, and so on, but you can at least pull out multiple pieces of the. And by the way, this doesn't just apply to the running config. This applies to any show command that you do, right? So for example, show IP route, we did see this before, but show IP route includes C. So take out all my connected routes. Show IP route include, let's see, L for local routes, and so on. So you could see where this could be very, very useful using these particular commands. And again, not something you're necessarily going to be tested on, but it does help because sometimes these configurations can get really, really large, or sometimes the outputs that you're trying to see are very, very detailed, and you're just trying to pull out specific information. All right. So those are very useful. I'm not going to run all these. I think you guys get the idea. Again, the include, the exclude, the begin, these are all going to be case-sensitive options. You could also do something like this, show run, return, and then I can hit the backslash and I can say time, backslash time. So I can filter through the running config by using the forward slash, I guess. Is it, yeah, forward slash. But that just does it chronologically, right? So if I do show run and I say forward slash AAA, I had already seen the AAA command in the first section. Let's do show run, and then we'll do forward slash line. So it takes me all the way down to the line section. Okay, so that can kind of be useful too. It's not as useful as the actual filtering commands that we have available to us, but it can be a little bit useful. All right, and again, that works in any show output as well. Exclude, in this particular case, they're just excluding the exclamation point, so they're basically getting rid of all the section breaks, if you will. I'm not going to run that command. All right, so that's it actually. That completes that discovery. Finally, we got through that thing. I know it was a lot of basic information, and again, not really relevant to the exam, but also very, very useful. So we'll wrap up this section and we'll get into the next section.